Hey there, 12. So let's look at this network here. This is a multiple choice question, VCAA 2012, multiple choice question 8. You've got 8 activities, so you've got all these edges here. That's 8 activities and must be completed for a project. The graph above shows these activities and their usual duration in hours. The duration of each activity can be reduced by 1 hour. Okay, so it can be reduced by 1 hour. Now, to complete this project in 16 hours, the minimum number of activities that must be reduced by 1 hour each is, okay, so first thing is, to do this activity, you need to find the critical path. So let's find the critical path, okay? So I would start off by adding them. So starting at A, this gives me 7 here. That's a bit small. Maybe I'll do this one. 7. This is now 3. But 3 plus the 4 is also 7 as well. So 7 looks like the best spot there. 7 plus the 6 gives me 13 here. And there's no other way. So 13 plus 4 now gives me 17 to get there. 7 plus 5 gives me 12. But then 3 plus 4 gives me 7. So clearly 12 is the better route. And then 12 plus the 6 gives me 18. So we can see that 18 is probably the best route that I can get, or the minimum amount of time to get it all sorted. So I would have to have gone either A. Ooh, that's big. Let's do it a bit smaller. So A. These 3 are critical because they can all still get to that point at 7, right? But from here, once I've got 7, I need to go down to 5 and then plus 6. So 7 plus 5 is 12, 12 plus 6 is 18, rather than taking this route. This route doesn't get me to the best account. So that means the minimum time required clearly is 18 hours. Okay, so that's my minimum time required. Now, it looks like to complete this project in 16 hours, so I want to get down to 16 hours, and all I can do is reduce activities by 1. Okay, so what activities can I reduce by 1, and what's this minimum number of activities that must be reduced by 1 hour each? So if I were to get to 16, I need to reduce at least 2 of these. So if I did A, for example, so remember the ones you're reducing are the ones on the critical path. So I can reduce A as an example. Ooh, that's a bit thick. I'm going to use a thinner one. So say I reduce A down to 6. So remember, you can only reduce by 1 hour. So 6, that gives me an overall 17 hours now. But remember, if I do that, then these also now become a critical path. True? Okay, so I would reduce that, and that would reduce it down to 17. Whoops, my pen's going a bit funny. 17 hours. So remember, if I did that to 6, this now becomes 6. 6 plus 5 is 11. 11 plus 6 is 17. But also keep in mind, what's the top value? That's now 6 plus 6 is 12, and 12 plus 4 is 16. So maybe it's still okay. All right. To get to 16 hours, I would need to reduce maybe, say, F, for example. If I did reduce F or H or anything on the critical path, if I reduce, say, well, if that's 6, actually, no. If I reduce this one to 6, the problem is this is still 7. So 3 plus the 4 is still 7. So that will make it a problem, because if that's 7, it's still, my finishing result is still going to be 18. You get what I mean? Because then that means A doesn't become a critical path anymore. It becomes 3 plus 4 is 7. 7 plus 5 is 12. 12 plus 6 is 18. So because of that, if I reduce A, it means I have to reduce either B or C. So I'll probably reduce C since I'm here. So C, if I reduce that, so I'd have to reduce those 2, and they both become 6. If they both become 6, 6 plus 6 here is 12. 12 plus 4 is 16 over here. And then down this critical pathway, 6 plus 5 is 11. 11 plus 6 is 17. Great. So that means I can still reduce another one. If I want to get down to 16 hours, I can reduce now F as an example. Okay. If I reduce F, that becomes now 4. Okay, and then 6 plus the 4 is now 10. 10 plus the 6 gives me 16. Okay, and that is still equivalent with the top row the top one also becomes a critical pathway, and 16 hours I've reached. Okay, now you might be questioning, why didn't I change B? Because if I change B down to 2, what this changes is that this now becomes 2 plus 3, 2 is here, and then 2 plus the 4 gives me 6, right? 2 plus the 3 gives me 5, and that's a problem, because if this is a bit hard to describe, but let me try to draw it again, just so you can see. If I had reduced that B, can you see, if I reduce B down to 2, and this is still down to 6, I reduce A and I reduce C as down to 3, can you see that this point here will have a result of 5 or 6? And so 6 still takes precedence because it's the larger value. So even if I were able to reduce this down to 5, it's still going to be 6 plus the 5, which makes it 11, and then 11 plus the 6 will give me 17. So I'm still on 17 hours. See what I mean? It doesn't make it down to 16. So that's why there was no point changing B at that point. B was currently 3. I chose to reduce F down to 4. And that way that will reduce the whole entire thing down to 16. That was the reasoning. Okay, so as you like to reduce these ones, you have to also make sure that the value at each point that you're looking at doesn't change so dramatically. So on the top here, we knew that it still finishes at 16. So that doesn't change. 16 is the minimum that I can do. And if your question was, why don't I, if this is going to add up to 5, why don't I reduce this by 1? It's because I already reduced it by 1. I went from 7 down to 6, and I can't make it 5 because I can't reduce it anymore. That's why there was no need to reduce B, and therefore the ones that I had reduced was A. A became from 7 down to 6, I minus 1. C, I reduced that in order to keep the critical path. So I had to reduce C by 1, okay? And then once I've got C, well then F was my next one that I changed, minus 1. And this should take off 3 hours overall. That's how I get 16. So you can see that it worked out to be, the critical path is still 3, so I'm just going to rub this out. There's 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 6 is 17. Oh, wait a minute. What did I do? So I went from 7, take away 1, now becomes 6. I reduce C from 4 becomes 3. And then I also reduced F from 5 to become 4. So let's calculate that again. It was 3 plus 3, which is 6. And up here has become 6. Yep, 6 is the largest value. So 6 adding downwards was add 4 gives me 10. 10 plus 6 is 16. Whilst on the top, 6 plus 6 is 12. 12 plus 4 is also 16. So my critical path is still maintained. And what I will have now is that the more critical paths I've got. So essentially I've got most of them as critical pathways. And the answer is, how many did I have to reduce? It was A, C, and F. So those were 3 activities that I had to reduce to get down to 16. So minimum number of activities that must be reduced by 1 hour. Answer has to be C. Okay, so I know that took 8 minutes to explain, but hopefully you can see where the intuitive part of what I was doing, but there's still a method that I'm doing. I'm still finding the critical pathway first, and then the reduction is where it's interesting. The reduction is where you want to spend time to make sure that you don't change the critical path too much. And really, a tip that I would suggest is that as you're doing it, the more critical paths you can create, that's probably going to be the minimum, or at least the answer you want. So you can see that my critical pathway, if I do it all again, okay, so it was here. I need to copy that picture again. Actually, you know what? I'm just going to do it again. Here we go. I'm just going to copy this one so you see what I mean. So just bear with me for a second. I know it feels confusing, but just give me a second here. My point is, the tip is, if you can make many of them a critical path, that is often the answer. That will be the final answer. So you see, initially my critical path was 3 to 3 plus the 4 is 7, 7 plus the 5 is 12, 12 plus the 6 was 18. Okay, so that was my value, 18. What I'm doing now, okay, is I then reduce this by 1, so 6, reduce this by 1 becomes 3, and then reduce this by 1 becomes 4, right? What you see is as I went through, I reduced this by 1 because 3 plus 3 gave me 6. If I didn't do that, this would have been 7, and this is still the critical pathway anyway. So as I reduced A, I had to also reduce C. Okay, so now you can see that they both end up at 6. 6 there, that means that this now becomes a critical path because that also gives you 6. True? Then, when I added 6, I noticed that I can also reduce F by 1. So 6 plus 4 now gives me 10. 10 plus 6 is 16. But notice that from here, 6 plus 6 is 12, and 12 plus 4 is also 16. So this now also becomes my new critical path as well. So what you can see here is I've highlighted most of this network, and that allows me to still give me a critical path of 16, and I can reduce it any further, especially with the cap of 1 hour per activity. Okay, so that's the thing. Even if I reduce this by 1 and became 5, and this is now 15, remember this pathway still is going to need 16. So that's why the minimum that I can reduce down to is 16, and the minimum activities that I could do before was then only, why is it such a different color? I don't know why I can't select what I want. Select, this is what I want to say. The minimum that I got just now was clearly 16, and 16 was the result of all of these are your minimum value. Okay, so that's your critical path, okay, to get 16. Cool. I think I just lost track what I was saying just now because of the color issue. But hopefully that made sense to you. Okay, so hopefully you can see crashing is about finding a critical path from exercise 15D, and then the more critical paths you can make usually is the most efficient result that you can do. Okay, I'll do another example as well to help you along.